Okay. Okay, just get this one. Okay, great. Okay. 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 Sorry for the problem here. Okay. I have problems showing my slides full screen, so you see them this way? Sorry for the problem. But okay. Most important thing is the message to say, so just forget about the slides. Or at least how you see them. Okay. So in this quickie talk, we're going to talk about Terrastore, which is a NoSQL database, a no-relational database. And I think you already heard about no-relational databases and NoSQL nowadays, today, sorry, a little bit. So I'll go quickly about the NoSQL stuff. Anyways, maybe you already heard about me in my previous presentation. I work as a software engineer in Win. I contributed several stuff to the open source community, and I'm a microblogger. Okay, why NoSQL? We have three problems we want to solve. We have a data model problem, where we have often a relational mismatch between our object and the relational database. We have problem with our schema, which we want to evolve. We have problem with the data access patterns, and we have problem with scalability. So how we try to solve such problems with NoSQL? Let's take a look at Terrastore, which is NoSQL Store. It is ubiquitous, meaning it is based on HTTP protocol and JSON format, which are pretty common nowadays. Every browser can handle them. Mostly any language has a client library for handling with both HTTP protocol and JSON format. So it is consistent. So if you recap all the discussion we have about consistency model and the CAP theorem, you may get it into focus. And Terrastore is a consistent store. It is distributed, and it is scalable, meaning that it will help you accomplish those hard tasks such as complex queries, aggregations, and any kind of computation which otherwise you'd have to perform on your own client, your own client application. Well, with Terrastore, you can do that in a distributed fashion. It's written in Java. It's based on Terracotta, which is an awesome clustering platform that is very industry proven, strong in the industry. It is open source and Apache licensed it. Okay. First point, your data, your documents, meaning that you don't have to, you don't have any mismatch, you don't have any conversion step to perform, any mapping. You have your data, and which can be easily mapped to a JSON document, which is pretty close to your object model often. So you don't have any mapping to actually perform. So that's a very simple representation of a person object. You can access Terrastore everywhere thanks to the HTTP protocol, and we already talked about that. you can keep your data consistent. And with Terrastore, we're talking about timeline consistency, meaning that you are guaranteed to always see always read and write your data in a sequentially consistent way, meaning that as we talked about before, your read and write operation will always operate on the latest read or written version of your data. It can be distributed as a single cluster, meaning that given the architecture slide where you have server and masters, because Terrastore is a master-based architecture, where you have the master, which in this deploy is an inactive passive. You have your master, which is your state of record, which holds your data, and then our servers, which actually handle requests and works as a memory-based store. You see that's the memory symbol. That's because all data in server is kept in memory and then persisted in the master. And you have request routing between servers. That's because Terrastore is partitioned other than distributed, meaning that you don't servers don't hold the full copy of your data. They share your data automatically with a consistent hashing. And then you need, obviously, to do request routing to know where to find what. That's about the single cluster. Or you can go multiple clusters, meaning that to overcome the single active master problem you were saying before, because you have one active master and one or more in that passive master. You can, with a multi-cluster setup, have many clusters joined together to work as a wall. So you can have actually multiple active masters. Okay, so we have a rundown about the Terrastore base concept and architecture, but why should I go with Terrastore? I have many options. Okay, so let's see what makes Terrastore so developer-friendly, ready for web development, which is probably the task everyone has to face nowadays when working at his day job. First, you can get started in seconds. Starting with Terrastore is just one single line command. It is based on ant, and this command just run a fully working cluster made up of one master and two servers, so you can just start working with a distributed database. Okay, you can easily install it. Once you get past the quick start phase, which is just for trying it, which is not for real use, you can easily install separated master and servers instances by just running some base ant command. You see this, you install the master by just saying, okay, install me a single master, this is the port of the master, this is the installation directory, and for the server it's almost the same. You just say the installation directory. Pretty easy. Configuration doesn't happen through XML files, stuff like that. It is just plain command line arguments, except for in case we'll see after. So you just say, okay, master start, and then you start the server by passing the master, the HTTP host port, and so on. So very unique style. And you can scale out easily with the multi-cluster setup by just providing the ensemble switch and the JSON configuration file. The ensemble is the only thing which needs a configuration file. And you just, in the example above, you're just saying, okay, I have a local cluster called Apple, which is the cluster the server I'm configuring runs on. I have a discovery interval of 5 seconds, 5,000 milliseconds. I have two clusters in there, Apple and Orange, and I want to get the membership for the other cluster by that seed. Okay, you have no impedance mismatch. Again, if you have your character with a name, a list of friends, and a list of foes, that's just JSON, which is pretty close to your object model. No distracting metadata. I mean, obviously, metadata is very useful. It might be useful to have version, timestamps, and stuff like that in the returned response. But everything you put into Terrastore, you will get back with nothing added. This is maybe a nerd, maybe a strong choice, but I believe this is simpler, and I believe it is more correct to implement things such as versions, timestamps, optimistic logging, stuff like that in your own. In your own model, rather than providing my way. Rather than providing the Terrastore way to implement optimistic logging and stuff like that, I prefer to say, okay, I'll get back to you what you put into, and then you could implement your own services on top of that. Very simple, basic operations. Everything is based on HTTP. Okay, so you have put, get, and delete, as you would expect with HTTP verbs, with JSON request and entering and a JSON response going out. You can do range deletes, again by using HTTP. You just say, okay, I'll delete the range in that bucket with a runtime specified comparator with a start key, end key, and a time to live. Just 2 words about the time to live, because the ranges are dynamic and they're dynamically computed, and they have a time to live, meaning that ranges actually works over a snapshot of your keys. Range queries work the same, absolutely the same. You just with deletes use the delete HTTP verb. With range queries, you just use get. Merge updates, meaning you can quickly update your document by merging stuff. You send a post request and you say, okay, this is my merge descriptor. I want to, in the example, add the new field and delete the old field. And this is quick. Pretty fast, and you don't have to do a round trip, such as taking back here the document you want to change, changing that in your client, and putting that into. You just send a merge update, a merge request, and everything happens inside the data store. Predicate queries. You can say, okay, give me all documents into the bucket which match the predicate, and the predicate is server-side specified. You have built-in predicates, so you can specify your own predicates by implementing them. Conditional put and get, working almost the same as the queries, but just acting on single put and get. And for example, with conditional put and get operation, you can easily implement optimistic locking with your own concept of version. MapReduce. You can apply MapReduce query over bucket and return an aggregation of documents matching the descriptor you provided. You provide start key, and you can provide a range of documents you want to apply MapReduce on, or you can provide no range, and then you will act on the whole bucket. And you must provide the task description where you specify the mapper, combiner, reducer to use. Timeout is very important, because if the computation doesn't finish for the timeout, it will be killed in order not to get stuck. Oops. Okay. Update functions. These are somewhat similar to merge updates, but with update function you can specify how to update your documents by providing a a user-specific function, which can be built in or which can be implemented by the user. And you can also use JavaScript-based functions. Okay. So we talked about several things by the server side. You can do you can use comparators, predicates, functions. How could I implement my custom stuff? This is an example of implementing a custom comparator for using range queries. You have just to do to annotate your implementation with another direct annotation, and then just implement the Terrastore provided interface. Same for conditions. Just apply your the autodetect annotation, implement the condition, and put it into the Terrastore class path. It will be automatically detected. Same for functions. Same for aggregators. Functions are used for update functions and for mappers. Aggregators are used for combiners and reducers in MapReduce. And you have more, obviously. You have backups, you have event management, you have custom data partitioning, meaning that the basic one is based on consistent hashing, but you can provide your own implementation and say, for example, okay, document A goes on node 1, document B goes on node 2, and you have full control over your partitioning. You have indexing and searching support through the awesome Elasticsearch product, which is third party. And you also have cross-origin resource sharing. I don't know how many of you have heard about cross-origin resource sharing, but it means you can call Terrastore by any browser, by any modern browser such as Chrome or Firefox 4, which supports the cross-origin resource sharing reference. Yes, time is up. So engage. Those are the links, and enjoy.